Hello. Let's continue Hoenli model. Let's go to the last part of our previous code, which is this one. And let's upgrade this code. So let's copy this one, copy cell, and then paste it to new cell. Let me check. Okay, this works. First, this one, we put two bond A2 and A3, but let us make it more general so that potentially we can put A4, A5, etc. So let's call it A and then delete this one. So we don't need this part. And then A. This is first period, so it is A2. So instead of A2, let's put this on A0. Okay, and then A2. Okay, A2. In fact, I can copy this one and remove this entire line and over here. Okay, and then this one looks fine. And then for this one, we have A3. So this is A1, second element. Okay, A1, A2, and let's define A equals list A2 and A3, A3, and let's put A over here. And then M1, M2, and then let's check whether the code works fine. The code works fine, okay? So we have a path of the interest rate. Okay, so far so good. And then next, since we have path of interest rate, now I think we can create the path of the bond. Okay, so we have two bond that matures at t equals 2. So the bond maturing in 6 months, and another bond which matures in 9 months. So let's analyze the path of that. So first, okay, first GCB3, okay, actually GCB6, GCB3 or GCB6, okay, so let's just call it GCB3, okay, GCB6, okay, because it's GCB6M actually, because it matures in 6 months. So we have this one, okay, and then obviously, okay, about the short rate, instead of this one, let's say t equals 0 over here, and then t equals 1, and then t equals 2, okay? And then for t equals 2, because the bond matures in 6 months, at t equals 0, we know the price is always 100, the face value, because we are assuming the risk-free bond 100. But at t equals 1, we have at the top, it is 0, but we have NU and ND. Okay. And at t equals 0, we would have a bond such that it is 0, Let's put comma over here. 0 and 0 and then and 0 initial one. So let's keep it. Let's keep the lines over here. And then we have to find the value of this one. So clearly, okay. So NU is clearly 100 multiplied by EXP. We so 3 months later, it becomes 3 months bond. So we have to discount it with these two rate RU and RD. So it is up. So we discounted the RU. Okay. And the DT. And then NT equals copy and paste now ND. And then N0 would be what? It is the 1/2 because it's Hyoung model. So NU plus ND because they occurs with 0.5%. And then we discount it with current 3 months rate. Change it to standard runtime. Okay. Change to standard runtime. Good. Okay. Now R0 multiplied by DT. Okay. And then let's tabulate, print, tabulate, tabulate GCB 6M headers. So we want to see the time. So keys, and then table format equals Presto. So let's see. So there is a error over here. Where is the R0? Exponentially not defined. So okay, let's run OR again. Okay, now it looks fine. So the 3 months bond. So the initial one is this one. 3 months later, it becomes this one, and 6 months later, it becomes 100 already. So this pass out bond is consistent with this one. So let me just check. Let me check the A. Okay. Print A. Okay. So A is 97. So right. The bond price of bond maturing is this one, and this is exactly the same to this one. So we are done. This is the path of the bond that matures in 3 months. Okay. And then how about the bond that matures in 9 months? So let's do that. So JCB 9 months. How about that? J must 9 months. So let's copy this one, paste, and then we have now T equals 3. Here we have 100, 100, 100, and 100. Okay. And then T equals 2. First one is 0. And then we have NUU and UD and DD. And let's say NTU and DD. And then 0, 0, NU and D, and then 0 and 0. Okay. So we have to fill now those values. And then I think we can see and UU equals, of course, face value 100 multiplied by EXP minus RUU, which we defined over here, multiplied by DT. And then NDU, RDU, and then I know it is inefficient coding, but it is robust and easy to understand. So let's just continue. So NDD is this one. And then NUND, okay. The N0 part would be same, but instead of this one, we have now 0.5 multiplied by, it is NUU plus NDU, and this is 0.5 multiplied by NDU plus NDD. Okay. There is error over here. So this is not necessary. T equal 3, invalid syntax, invalid is while. Okay, we need a comma over here. I hope it works now. And then, okay, let's see 9 months bond. Okay, so we have this. So the bonds maturing in 9 months, the path looks like this, and the initial price, this one is consistent with this one. So everything is consistent to each other. Okay. So far, so good. But again, this is still inefficient. So let's enrich this class over here. So what we can do is, okay, what we can do is, I think, okay, we can create path of the interest rate over here. So we have path of the interest rate over here. So I think we can include it to the class. So let's say define a function rpath, and then again we need the initial case. So self m, and then we can let's copy and paste this one m0, and then let's copy and paste everything, this one. Over here. Okay. And then M0, this should be N1 because we know optimal value. So M1 is, let me say, M1. So, okay, like this one. So why is actually, let's make the code simple. So instead of this one, I put over here. And then instead of this one, I put this one over here. Okay. And then, okay. Path. Now we can short rate data over here. Let me copy this one and paste over here. And then, okay. is fine. And then let's return tabulate short rate data. Okay. And then let's check this value. So here, let's print. Okay, actually print this one bar so we can distinguish. And then print bond one. And then what was the name? Bond one. And then this is R path. Okay, bond one. And then pass. And then initial gas 0.01. Let's see. Okay, so let me say this path is exactly same to this one. Okay, so we are fine. This one instead of this one. Let me use these stars. Okay, so that yes, now we have a star. Now it is easier to distinguish. Okay, so we have a path of interest rate. So right, this is looks much easier. And then let's print out the path of the bond as well. Define GCB 3M over here. GCB 3M. The name is the same. So, okay, now here on the bar, okay, to distinguish our previous one. So self M, okay. And then GCB 3 months, self M. And then again, we can copy 3M. So I think we need only this part. Okay, it is inefficient coding, but anyway, let's continue. Okay, and then okay, and then GCB 6 months over here. Okay, not 3 months, 6 months, okay? Okay, and then return GCB 6 months. GCB 6 months. Okay, and then here, now print GCB 6 months. Let me check. Ah, this is nasty, but the answers, we should be same to this one. The answers seems all right. So, okay. So where was it? Where was it? Okay. Not just written, we can tabulate this one. Tabulate. And then we have this one, and then the path of the 6 months bond. This is exactly same to this one. Okay. And then similarly, we can create the GCB 9M. And then self M. And then we can, well, let's copy over here. RUU are the this one over here. Again, it is inefficient, but it is easy to understand. So let's just continue. And then move is a bond price, and then okay, and then we can return tabulate GCB. Okay, GCB 9M. Okay, let me save. And then over here, okay, here, let us use class. Okay, and then print 9 months, Control Enter to run the code. And then we have this one, and then this value is exactly same to this one. Okay, so again, we found, we calibrated basically path of the interest rate, which is consistent with the bond we observe. Actually, bond that we observe, which is A over here. The price of bond maturing in 6 months, the price of the bond maturing in 9 months. So this path is consistent with this part. Okay, so the movement from here to here, this part, here to here, this part is consistent with this price of bond, and movement from here to here is consistent with this part, right? And then indeed the initial price all consistent. So we calibrated the path of interest rate, and we again give this interest rate, we can find the path of the evolution path of the 6 months bond like this, and the evolution of 9 months bond like this. And then thank you.